Hello everyone, welcome to today's class. This is teacher Simon taking you through Probability and Statistics 1. This is paper 970152 May June 2025, and this is part 1 for questions 1 to 4. Question 1. Rachel has 3 coins. The first coin is biased so that the probability of obtaining a head when it is thrown is a third. Now, the coin which is unbiased, the probability of getting a head is a half, and also the probability of obtaining a tail is also a half, because there are two outcomes, head and the tail. But because this one is biased, then you are not going to have the probability of a head, neither that of the tail being a half. Okay, so for this case we are having a third. The second coin is biased so that the probability of obtaining a head when it is thrown is a quarter. The third coin is fair. Now for the fair coin, you can say unbiased or fair coin. That one, the probability of obtaining a head is a half, and that of the tail. Rachel throws the 3 coins at the same time. The random variable x is the number of tails that she obtains. Draw up the probability distribution for x. I'm going to draw a probability tree diagram here. So the first coin here, we get a head and then the tail. The second one here, head, tail. Same here. And then the third one here, head, tail, head, tail, head, tail, tail. Now, the first one, they said it is biased, and the probability of obtaining a head is a third. That means the one for the tail is 2/3. Then the next one, a quarter, and then this one will be 3/4. Same here, quarter, 3/4. And then the third one is fair. That means we shall have a half everywhere. A half. Like that. Now when you throw the coins, there is a possibility of you not getting any tail. Okay, so that means for no tail, I'll get that as probability of x is equal to 0. That is if x is the random variable for obtaining the number of tails. So this is the same as saying we get all heads. Okay, and we are having all heads. The option is here. So we have a third, then times a quarter, then times a half. 3 times 4, 12, times 2, 24. So this one will give us 1 out of 24. Then probability of x is equal to 1. We have 1 tail. So we can have head, head, tail. Okay, this one here. Then we can have head, tail, head, head, tail, head. In other words, after this one here, you move this t until it comes here. Okay, then lastly, we are going to have tail, then head, head, tail, then head, head. So head is a third, and then another head is a quarter, then the tail is a half. Then head, tail, head, tail, then head. Then lastly, we have a tail, which is here, then head, head, a quarter, and then times a half. This one is 1/24. Then this one will be 3/24, and then 2 out of 24, meaning we shall get 6 out of 24, which can be simplified as a quarter. Okay, but I'm just going to leave it there. Let's go to probability of x, which is equal to 2. So 2 tails. We shall begin with this one, head, tail, tail. Then there is tail, head, tail, and then there is tail, tail, head. See? So we have head, tail, tail. In other words, move this h up to the end. Plus head, no, it is going to be now tail, then head, and then tail. Then lastly we get we have head, tail, tail, head. Let's substitute the values. Head, tail, tail. So we have a third, then 3/4, and then a half. Then this one, the tail is 2/3, head is a quarter, and then a half. Then the tail here is 2/3, and 3/4, and then a half. So this one is 3/24, 2/24, and then 6/24. And when we add everything together, that will be 11/24. Then lastly, x is equal to 3. All three tails means you have tail, tail, and tail. So we have 2/3 times 3/4 times a half, which is going to be 6/24. Then from there, we can draw our table. We have x here, and then probability of x is equal to x. So we have 0, we have 1, we have 2, we have 3. For 0, it is 1/24. For 1, it is 6/24. For 2, it is 11/24. And for 3, it is 6/24. Now, when we add 1 plus 6, that is 7, plus 11, 18, then plus 6, that is 24. So 25/24, that will be a 1. So you remember, for any probability distribution, the total is a 1. Okay? The total of the probabilities is always a 1. Now let me draw the table. Let me put everything in the table. So that is that. Question 2. In Milford, 70% of the residents own a bicycle. A random sample of 160 residents is selected. Use a suitable approximation to find the probability that more than 120 of these residents own a bicycle. Okay, now this is, first of all, since they have given us the probability of the success for those who own a bicycle, this is a binomial, and n is also known, 160. Okay, but then if they say more than 20, then we have x greater than 120. That means we shall consider 121, 122, 123 up to 160. When will you finish? You won't. So that means we need to approximate this binomial to the normal distribution. Okay, we approximate the binomial distribution to normal distribution. And there are two things that we must consider. Number one, we need to find the mean. And mean of a binomial is NP. Okay, mean of a binomial is given as NP. You can even check in the list of formulae. N is 160, P is 0.7. Then there is standard deviation. We need these two in normal distribution. Okay, so standard deviation is going to be root of variance, root of NPQ. So our n is 160, p is 0.7, then q is 0.3. Then what do we get inside here? 160 times 0.7. First of all, that is 112, then times 0.3, 33.6. So 33.6 here under the square root, and this is 112. Now we need to carry out the continuity corrections. We need to carry out continuity corrections. Now we do this because we are moving from discrete random variables. So for discrete random variables, that is where we find the what? The binomials. But then when you are going to normal distribution, you need to, this one deals with continuous random variables. So you need to get the continuity in the numbers, okay? In O level, you did what we call bounds. You used to find upper bounds and lower bounds, okay? In statistics, when we are plotting, let's say, cumulative frequency curves and then histograms on the horizontal axis, we always plot what? Class boundaries, continuity of data, okay? So here we are having more than 120. I have just something small here to show you how we are going to carry out the bounds. So if this is 120, a number before it is 119, a number after it is 121. But we have in the middle here, that is where 120 starts, and then this is where it ends. This is 119.5. This is 120.5. The numbers that are here, when you round them off to the nearest whole number, they'll give you 120, same as the ones here. But when you come to this 120.5 and you round it off to the nearest whole number, you'll instead get 121. So that's why in O level they used to give you something like this. They could put, if this one is about, let's say, masses or whatever, they could say m, then less than or equal, they put a dash here, then here they put less than. They don't put less than or equal here. Why? Because when you round off this number, it no longer gives you this one. You get it? So for this case, we see 120 lying within this region here. So we have 120, and this is 120.5. And then this one is 119.5. Now we are looking for probability of x greater than 120. We need to standardize, okay? Now this one, when we round off, we need to, by the way, you are supposed to either use this upper bound or the lower bound, okay? We have to choose one of them. So when you round off, which one are you going to round off such that what you get is more than 120? It has to be automatically this one. When you round this one off, it will give you 120. But this one will give you more than 120. So that's why I've always said that if they give you greater than, you add a 0.5. If they give you less than, then you subtract a 0.5. If they give you greater than or equal, when they say like at least, something like that, then you subtract a 0.5, and then for less than or equal, you instead add a 0.5. If you keep this, it will help you. So this is greater than, that means we are going to add a 0.5. So this will be x greater than 120.5. Now we standardize. This one is going to be probability of z, then greater than. Remember, z is equal to x minus mu out of the standard deviation, not so? So we have the x is this one here, minus the mean, which we have calculated here as 112. Then we divide by the standard deviation, root of 33.6. Okay, and then from here, I can put everything in the calculator here. So if you have such a calculator, you can press mod, then you go to 3, that is where there is start, 3, and then from there you press SC. Now you look onto your screen, you will get start there. Then you press shift, then 1, that is where there is start. Then after that, distribution, that is normal distribution, it is option 5. And then after that, P is for less than. Q, it is from 0 to the certain value of Z. Remember, we have something like this. This is the barrel-shaped curve for the normal distribution. Its mean is 0. So if I have a Z value here, then the less than, that is the P, okay? Then the whole of this gives us the P, okay? Everything here. Then R is for greater than. You get it? And then from 0 to the Z value, that is the Q on the calculator. But we are interested in the greater than, okay? So when I come back here, the greater than is R, so I will press 3. Then I put this expression here. We have 120.5 minus 112. Then this one we shall divide by the square root of 33.6. Then we close the brackets. 0.071271. And of course, to 3 significant figures, we shall have 0.0713. Okay? But you can also use the table. When you're substituting here, some people write this one in decimals. So when you're writing here, you can put this one to 3 decimal places, okay? 3 decimal places, because when you go to the table, we are given 3 decimal places. You see that? So this one I've used the calculator. I can even put cal, okay? I've used the calculator, and the calculator gives me up to 5 decimal places, okay? Alternatively, we are going to use a table. So this probability of Z greater than 120.5 minus 112 out of the square root of 33.6. This one is going to be equal to probability of Z, then greater than. I'm going to put 3 decimal places there. 120.5 minus 112. Then we divide by the square root of 33.6. That is 1.466. 1.466. Now, when we sketch the normal distribution curve, okay, and this one is a positive number, so it is on the right of the mean, 1.466, which mean is 0 for the standardized one. Now we need this one here. Since in the list of formulae or on the normal distribution table, we are given the probability of the less than, okay, this one here. Now for me to get this one, it will be the same as saying 1 minus probability of the less than, okay? All right, now we go, and here it doesn't matter. This one is not included, and then here you don't need to put less than or equal, okay? For normal distribution, this is just a boundary, okay? Then we go and check this one here. Now in the list of formulae, this is the normal distribution table they give you, okay? And they are saying that phi of Z is probability of Z less than or equal to the Z. You can even see the shaded region just for the less than. Now we are looking for probability of Z less than 1.466, okay? Now 1.4 is here, then 6 is here. So where do they meet? They meet here. So we have 0.9279, and then there is a 6, this 6 here. The last one is this one here. So you go down up to this line here. So we are seeing 8. So add it from the end here. Okay. Now when we add, what do we get? 9 plus 7, 9 plus 8, that is a 17. Add the 1 here, that will be 8. This will be 2, and then 9. So we take this one, 9 to 8, 7. 0.9287. Now, when we subtract here, what do we get? 1 minus 0.9287. We get 0.03, 0.0713. It is even to 3 significant what? Figures. Now, do you see that we get the same answer here? So that is that. And here I can even say I've used the table. So I can put tab. Just like that. Question 3. A bag contains 4 blue marbles and 12 red marbles. One marble is selected at random from the bag. If this marble is blue, it is replaced in the bag. But if it is red, it is not replaced. A second marble is now selected at random from the bag. Part A. Find the probability that both marbles selected are of the same color. Okay, now let's draw a simple probability tree diagram. So we have blue and then red, and then the next one can also give us blue and red. Also here, blue and then red. Now, probability of picking blue will be 4, then out of 16, because the total will be 4 plus the 12, right? And then this one for the red will be 12 out of 16. Now we are picking without replacement. That means the totals keep on reducing. Not so. They said that one marble is selected at random from the bag. If the marble is blue, it is replaced in the bag. So it is blue, then it is replaced in the bag. That means the blue marbles are still 4. So the probability of picking a blue marble from there is still 4. Then out of what? 16. The same for red. Red is going to be 12 out of what? 16. Now, they say that, but if it is red, it is not replaced. Now, that means we have taken out the red. The totals are now 15. Okay? Then, the probability of picking a red from there, again, it is going to be 11 because it has reduced by 1. And blues, they are still 4. Okay? Though the whole total reduced to 15. Now, they want us to get the probability of same color. That means we can have blue, blue, or red, red. You see that? So blue, blue will be 4 out of 16, then times 4 out of 16. Then red, red will be 12 out of 16, then times 11 out of 15. Okay? And of course, in probability, when we say all, means a plus. Okay? Now, what do we get here? This one is going to be 16 out of 256. Then plus this one here is going to be 132. Then how about this one? 16 times 15. 16 times 15, 240. So when I add these two and then I simplify them, what do we get? 16 out of 256, then plus 132 out of 240. We get 49 out of 80. 49 out of 80. That is that. And then part B, find a probability that the first marble is blue given that the second marble is red. The first marble is blue given that the second marble is what? Red. That means we are going to have probability of blue intersection red, then out of probability of getting a red. Now, here we are going to have probability of getting red. Okay, given that the second marble is red. we have blue and then red. Isn't that 4 over 16? And then red is 12 out of 16. This is the one we are having here. Okay. Then the second marble is red. So we can have this one here, blue, red, not so? And then we also have red, red. That is the total probability for getting red. So we shall divide by 4 out of 16 times 12 out of 16, then plus 12 out of 16 times 11 out of 15. Then altogether, what does this one give us? 4 out of 16, then times 12 out of 16. Down here, we also have 4 out of 16 times 12 out of 16. Let me first close these brackets here, like that. And then we have another one here, plus 12 out of, pardon me, let me put brackets. So 12 out of 16, then times 11 out of 15, like that. So we get 15 out of 59, the simplified one. 15 out of 59, as simple as that. Question 4. Vehicles approaching a certain road junction from Bromley must go either left, right, or straight on. Over time, it is known that 30% turn left, 25% turn right, and 45% go straight on. The driver of each vehicle chooses a direction independently of all other drivers. That means it can either be a GP or, a geometric distribution or a binomial distribution, because the outcomes are independently of each other and the probabilities of successes can be picked from here. All right. Now they are saying part A, find the probability that the next 3 vehicles approaching this junction from Bromley all go in different directions. Okay. Now, all go in different directions. I can have the first one going left, the next one straight on, the next one right. Okay. Or we can have the first one left. Okay. In fact, I'm going to simplify this one here. I'm going to simplify it this way. We have left, straight, right. Then left, right, straight. Then what is straight, left, right, straight, right, left. And then we can have right, straight, left, then right, left, straight. This one here is giving us 3 factorial, which is equal to 6 outcomes. You see? So the probability that we are going to get here is going to be the one for the straight. Let me just pick out one. Left, straight, then right, but then we shall multiply it by 6 because there are 6 outcomes. Okay, times 6. So now for the left turn, it is going to be 0.3, then times the next one is 0.45, and then the other one is 0.25. Then from here, we multiply by 1? By 6, because in all of them, you have those probabilities there. Okay, so you multiply by 6 because there are 6 what? Outcomes. So what do we get altogether? 6 times 0.3 times 0.45 times 0.25. We get 81 out of 400, which is 0.2025. 0.2025. It was exact. I don't need to round it off to 3 significant figures. Then part B, Find the probability that from the vehicles approaching this junction from Bromley today, the first vehicle to go left is before the 9th vehicle. Now that means we don't know the number of vehicles that are there, okay, that are taken into account. So for this case, this becomes a GP, okay? This becomes not a GP, geometric distribution, sorry. This becomes a geometric distribution because n isn't fixed, okay? The number of times the experiment is done is not known. All right, now I'm going to draw a simple tree diagram here to base on, okay? We are going to have, remember, in a geometric distribution, when you get the success, you stop. But when you fail, you continue. So P, Q, P, Q, P, Q, then P, Q, P, Q, P, Q, P, Q. And they said is before. Okay, if they say is before, that is less than 9. So we have, well, we are supposed to sum up to 8. So you have the P, Q squared P, Q cubed P, Q power 4 P, Q power 5 P, Q power 6 P, Q power 7 P. But do you those are the ones that you are going to add all together. But do you realize that only this one is left out? And you know that total probability is always equal to 1. Okay, so this simply implies that we can, let me just extend this one here. For probability of X, then it is less than 9. I will say the total probability, which is 1, then minus Q power 8. Okay, Q power 8. This one that is left out, if you have time, you can say P, then QP, and the rest of those that I said before, okay? You will still get the same answer. So this will be 1 minus, our Q is 0.7, then to the power of 8, okay? Because they said the first vehicle to go left, that means our P. When you go back here, to go left is 30%. So it is 0.3. So meaning the Q is going to be 0.7. So that's why I'm putting 0.7 here. And then putting this one in, in the calculator, what do we get? 1 minus 0.7, then to the power of 8. We get 0.942. 0.942. That is to 3 significant figures. That is that. And then part C, they're saying that find the probability that from the vehicles approaching this junction from Bromley today, the second vehicle to go left is the 7th one. The second one is the 7th one. So we have 1, 2, 3, 4, 5, 6, 7. Okay. Now, the 7th one here goes to the left and its probability is a 0.3. That means in here, in the first 6 vehicles here we are seeing, we are having only 1 success. They are saying the second vehicle is the 7th one. That means the one that turned left before can be the first one, can be the second one, can be the third one, can be the 4th one, can be the 5th one, can be the 6th one. So that means in here, I'm having 1 success going to the left, okay? And 5 what? Failures. So in those, the probability here, it is going to be out of the 6, I have 1 success. So that is 0.3 turning to the left. And then 0.7, the failures here, we are going to have 5 of them, you see? So I treat this as a binomial. Or you are going to have 0.3, then times 0.7, Okay. Maybe it is in the first position here. That is where you get the one that turns to the left. Then all of these ones are 0.7. Okay. And so this is 1, 2, 3, 4, 5, 6, 7. And these ones, there are 5 of them. So that's why we are putting power 5. Then you also consider when the left one is here. Okay. When it is also here, when it is also here. So it is going to appear 6 times. That is the 6 combination 1. So that's why we treat it as a what? As a binomial for that case. So then after that, we shall multiply by this 0.3 here as the last one. So putting everything in, actually you might find in the schemes when they have said 6, then times. Now this one and this one here, they will give us 0.3 squared. And then you have the 0.5 what? Power 5. So what is this to 3 significant figures? 6 times 0.3 squared times 0.7 power 5. That is 0.0908. 0.0908. 3 significant figures. Remember, 0 is not a significant figure, but it becomes so if it is in between other what? Figures. So this one is not a significant figure, this one is not, but this one is because it is in between 9 and what? And 8. Okay, so that is that. So this has been it for this first part of the paper. Thank you so much for watching. May God bless you. If you find the content very helpful to you, kindly like, share, and even subscribe. See you in the next videos.